Hi everybody, I hope this video finds you well. In today's video, we're going to be moving on to our next type of hypothesis test and confidence interval, and we're going to begin talking about what is called the two-sample proportion procedures. So this is going to be sort of the natural step from what we've been doing in the most recent set of videos, which is the one-sample proportion procedures. Now we're going to turn to what happens if you have two separate samples of binomial or Boolean categorical data from two separate populations. And this is very similar to what we did as the natural extension when we were working with one sample and two sample mean procedures. We started with what to do with one sample, and then we moved on to what to do with two samples. So we're now ready to do that here. So to begin with, we're going to talk about the two-sample proportion hypothesis test. This hypothesis test is used when you have two samples of binomial or Boolean categorical data from two separate populations that you want to compare. So you basically have two samples of binomial or Boolean categorical data. So again, categorical data where people were only given two options, and those two samples are coming from two separate populations, and you want to compare those. So let's go ahead and look at the 5 pieces of this hypothesis test. So to start with, the hypotheses. You'll notice that the null hypothesis is already written out because the null hypothesis is always going to be fixed when doing one of these two-sample proportion hypothesis tests. The null hypothesis is always going to be that the proportion from population 1 equals the proportion from population 2. In other words, our baseline assumption is going to be that the percentage in one population exactly equals the percentage in the other population. For the alternate, you guys will again have free sort of choice. You can think that P1 is going to be greater than, less than, or not equal to P2. And we will use the same sort of terminology, greater than. We will call that right-sided. And if we do less than, we will call that left-sided. And if we use not equal to, we will call that two-sided. And once again, that will impact how we calculate the p-value. If it's right-sided, we will be using 1 minus what we find on table A. If it's left-sided, we'll just use what we find on table A directly. And if it's two-sided, we'll actually have to find what's in both tails, usually using the negative z-score and then doubling what we find on table A. All right, what about the conditions? Well, as usual, when you have a two-sample procedure, the conditions require that both of the samples pass the standard conditions. So, as usual, we'll have that both samples must be random and representative. And for condition 2, we'll have that both sample sizes must be less than 5% of their respective population sizes. So, these two conditions, as always, stay pretty much the same. For the third condition, for the one-sample proportion procedures, we have that NP1 minus P must be greater than or equal to 10. That doesn't really work in this situation because there is no null hypothesis value. The null hypothesis in this situation is just that the two percentages are equal. It doesn't say that they're equal to a particular value. So instead, we use something more similar to the one-sample proportion confidence interval condition in terms of that we need to look at the observed successes and observed failures. So this says that both samples must have at least 5 observed successes and 5 observed failures. So you need to have 5 successes and 5 failures in your first sample and at least 5 successes and at least 5 failures in your second sample. So we have to make sure that that happens in each sample. Then for the test statistic, it'll still be a z-test statistic. And it has one of the more complicated sort of formulas that we've had for test statistics. In the numerator, we have P1 hat minus P2 hat, where P1 hat is the first sample proportion and P2 hat is the second sample proportion, divided by the square root of this P tilde, 1 minus P tilde, times 1 over n plus 1 plus 1 over n plus 2. So let's go ahead and just make a little list of what all these things are going to be. P1 hat, as we know, that'll be the successes in the first sample divided by the first sample size. That's our first sample proportion. P2 hat, that will be the successes in the second sample divided by the second sample size. N1, of course, that's the sample 1 size. N2, that's the sample 2 size. The only thing that maybe we haven't really been exposed to before is this P tilde. And this P tilde is what is called the pooled sample proportion. So this is called the pooled sample proportion. And basically what happens is with this P tilde, right, it sort of says, well, let's operate under the assumption that the null hypothesis is true, that the percentages are equal. So we're able to pool the samples together and look at what was the sort of percentage when we combine those two samples. So the way you calculate this pooled sample proportion is you add the successes from both samples and you divide by the total sample size. So this pooled sample proportion is calculated by adding the two successes, the successes from sample 1 and the successes from sample 2, and then dividing by the total sample size. So a little bit more complicated because it actually has a value or a variable here that you need to calculate separately that isn't going to just be from your raw data, but this gives us the test statistic for this two-sample proportion procedure. For the p-value, this should be very similar to when you did the one-sample proportion. Because this is a z-test statistic, you'll be using table A, the normal distribution, and of course you'll need to use the direction of the alternate, whether or not it is right-sided, left-sided, or two-sided. For the conclusion, this piece never changes. If the p-value is less than alpha, we will be rejecting HO, which means we have significant evidence for our claim. If the p-value is larger than alpha, we will fail to reject HO, and that means we will not have evidence for our claim for HA. All right, so this is your two-sample proportion procedure. Again, this is used when you want to tell if there's a sort of, if you want to compare two samples of this binomial or Boolean categorical data from two separate populations. There is also a corresponding confidence interval, so let's talk about that, and then we'll get to our example. So the two-sample proportion confidence interval, this is used when you have two samples of binomial or Boolean categorical data from two separate populations, and you want to use these to estimate the difference in percentage between these two populations. So in other words, this two-sample proportion confidence interval is used when you want to know the difference between the two populations in terms of percentage. Because again, whenever we're working with categorical data or proportions, we've got to always think in terms of percentages here. Now, the nice thing is that unlike the one-sample proportion confidence interval, where it had that different condition 3, the two-sample proportion confidence interval has the same conditions as its corresponding hypothesis test. So if you've already done the hypothesis test, the conditions are going to match exactly. In terms of the construction, again, one of the sort of messier formulas here, so let's talk about the pieces. The point estimate for this kind of constant confidence interval is going to be P1 hat minus P2 hat. So we take the difference of the sample proportions. Then the margin of error part is going to be Z star, again, because there is no need to do any estimating of population standard deviation, so we can get away with just the normal distribution here. And then this sort of messy expression, square root P1 hat times 1 minus P1 hat over N1 plus P2 hat 1 minus P2 hat over N2. You'll notice that in this formula, there is no mention of that pooled sample proportion like there was in the hypothesis test, because when you're doing the confidence interval, you cannot assume, you're not working under that baseline assumption that the percentages are equal. You're actually trying to see how different they are, so you actually have to deal with these separately. So there's no pooled sample proportion here, none of that P tilde. Again, just as a little list here, P1 hat, that's S1 over N1. N1, that's sample 1 size. P2 hat, as we mentioned, that's the successes from sample 2 divided by sample 2 size. N2, that is your sample 2 size. And finally, Z star, as we know, that comes from taking the Z star and your confidence level and intersecting those guys, and that occurs on table C. Okay, that looks a little bit ugly, so I'm just going to touch that up. Sorry about that. All right, there we go. So on table C, you can find that Z star based on your confidence level and the Z star row at the bottom. Okay, so now we've learned another hypothesis test and another confidence interval. We're going to jump into an example right away so you guys can sort of see how to use these new procedures. I do want to make one comment, though. We have a few more hypothesis tests to still learn in our class, but this guy right here does mark the last confidence interval that we're going to be learning. The remaining sort of procedures we'll be talking about for our class will only have hypothesis tests. So this actually does mark the end of sort of the new confidence intervals for our semester. So let's go ahead and take a look at an example here. So we're going to suppose you want to study if there is a difference in the percentage of U.S. adults who believe global warming is a serious issue compared to the percentage of Canadian adults who believe global warming is a serious issue. So to study this, you randomly select 250 U.S. adults and 150 Canadian adults. you find that 155 of the US adults and 114 of the Canadian adults believe that global warming is a serious issue. What we want to do is we want to carry out at alpha equals 0.05 a hypothesis test to test the claim that there is a difference in the percentage of US adults who believe global warming is a serious issue compared to Canadian adults. Then we're going to build a 95% confidence interval for the difference in the percentage of US adults who believe global warming is a serious issue compared to the percentage of Canadian adults. And then we're also going to describe the type 1 and type 2 errors in this situation. Once again, there should be no doubt that in this sort of question, we're talking about categorical data, right? You see the mention of percentage throughout this question. That's an indicator that it's categorical data. And also, if you just think about the question that's being asked, do you believe global warming is a serious issue? That is a categorical question, and specifically it is a binomial categorical question. You're saying either yes or no. Certainly in the hypothesis test, because we're studying the percentage of US adults compared to Canadian adults, well, that tells us that this is going to be a two-sample proportion hypothesis test. So for A here, we're going to be running a two-sample proportion hypothesis test. So let's go ahead and look at our hypotheses here. So we know that the null hypothesis is that the percentages or the proportions are going to be equal. We can say P1 and P2, but it might just be easier to go ahead and use some subscripts here. So we can say P, and then I guess for America equals P sub C. So we have that the percentage of people in America that believe global warming is a serious issue is going to be equal to the percentage of Canadians who believe that as well. Then for the alternate, we have our claim. Well, if we look here, we're trying to claim that there is a difference in the percentage. So we're going to be using not equals to here. And that means that this is going to be a two-sided test. Now, would it be okay to put P sub C or the Canadian percentage first? Absolutely, as long as you stay consistent with that. The only reason that I'm putting the American percentage first is because the data was sort of given with the American information first, so it'll help us just keep track of that. But certainly, as long as you stay consistent, you could reverse which one is sample 1, which one is sample 2. All right, let's go ahead and look at our conditions here. So we need both to be random and representative. And that, of course, has been stated. They were both random samples. Then we need both samples to be less than 5% of the population size. Well, what are our two populations here? Well, we're talking about all U.S. adults and all Canadian adults. So there's certainly lots of those. So we'd say lots of U.S. adults, check, and lots of Canadian adults. Check. We don't mean California there, we mean Canadian adults, right? But there we go. We've got lots of both of our groups, so we're certainly sure that our 250 and our 150 aren't going to be too much there. And finally, for condition 3, we need to talk about the successes and failures. So let's talk about the successes for the American group, right? In the American group, 155 people said that they thought global warming was a serious issue, so that's 155, which is greater than or equal to 5, check. What about the failures for the American group? Well, since we had 155 people say that it was a serious issue and we talked to 250, we can do 250 minus 155 and realize that there were 95 people that said it was not a serious issue. And so that would be greater than or equal to 5, so we're all good there. Now we need to do the same for the Canadian group. So the successes in the Canadian group were equal to 114, because the 114 people said it was a serious issue. That's greater than or equal to 5. And the failures in the Canadian group, well, we talked to 150 Canadians, so 150 minus 114, it looks like that would be 36, said that it was not a serious issue, which is greater than or equal to 5, so we're all good. So notice that we're just confirming that in each sample separately, the number of successes and the number of failures is both greater than or equal to 5. All right, we're now ready to go ahead and do our test statistic here. So our test statistic is going to be that z equals p1 hat minus p2 hat divided by the square root p tilde 1 minus p tilde 1 over n1 plus 1 over n2. So we've got a lot of things that we need to calculate here. P1 hat, N1, P2 hat, N2, and then also this P tilde before we can plug into this. So let's think about the sample proportion for our first sample. So our first sample is the American sample, and we just said that there were 155 successes out of the total 250. So it would be 155 divided by 250. If you do that on your calculator, 155 divided by 250, you'll see that that came out as 0.62. So in other words, 62% of our US sample said that global warming was a serious issue. The sample size was 250. For P2 and N2, that's going to reference now the Canadian sample. For P2 hat, there were 114 people who said it was a serious issue out of 150. 114 divided by 150, we should find that that's 0.76. So 76% of our Canadian sample said that global warming was a serious issue, and the sample size was 150 there. Notice that this also should show you guys why we do everything in terms of percentages here. Notice that there were more Americans who said that global warming was a serious issue, 155 versus 114, but the percentage was lower because we talked to more Americans overall. If you actually look back at the successes and failures, there were more Americans who said that it was a serious issue, and there were more Americans who said it was not a serious issue, because there were simply just more Americans in our data. So it's always important to be thinking about these things in terms of the percentages, not the raw successes and failures when we're actually analyzing the data. In terms of calculating P tilde, we're going to add the successes together. So 155 plus 114 divided by 250 plus 150. So we're adding the successes together up top, and we're adding the sample sizes together in the denominator. Up top, we're getting 155 plus 114, that's 269 out of 400. And then if we do that division, 269 divided by 400, we should see that that comes out as about 0.673. Now, a couple things to just mention here in terms of what this calculation is really doing. What this is basically saying is let's combine our two samples together. Let's forget that we had 155 Americans and 114 Canadians that said it was an issue. Let's just think about that as 269 people said it was an issue. And let's forget that we had 250 US adults and 150 Canadian adults in total. Let's just think about that as 400 adults in total. And this tells us that basically 67.3% of people that we talked to thought that global warming was a serious issue. You should also notice, just from like a number sense, that this guy is in between 0.62 and 0.76. And also this guy is a bit closer to 0.62 than it is to 0.76 because there were more Americans in our sample than there were Canadians. So this value here, your pooled sample proportion, will always land between the individual sample proportions, and it'll always be closer to the one that was part of the larger sample. So just some interesting little comments there. Let's go ahead and pop all that stuff in there and actually go ahead and do our computation. So we'll have z equals, our first p hat was 0.62 minus the second p hat, which was 0.76, divided by the square root. We find that p tilde was 0.673, so 0.673, 1 minus 0.673, 1 divided by 250 plus 1 divided by 150. Close up the parenthesis and just draw that square root a little further there. Okay. Now, as always, we'll do the top and bottom separately. So 0.62 minus 0.76. So we'll get minus 0.14. And then in the denominator, if you guys go ahead and you type this in with the parentheses that are written there, you can type it all in one line. So square root, parentheses, 0.673, times parentheses 1 minus 0.673, close the parentheses, times parentheses 1 divided by 250 plus 1 divided by 150, close up the parentheses, and we can get our enter there. And we should get something, if we keep 3 decimal places, 0.048. Then we can go ahead and do our division, negative 0.14 divided by 0.048, and looks like we should get negative 2.92. So there's our z-score. We can go ahead then and get our p-value from this. So we can do our p-value. We'll go ahead and draw our little diagram. There's our null hypothesis. Our z-score is negative, so it is somewhere over here. Z equals negative 2.92. Now, remember, we are doing a two-sided test, so we want to draw the mirror image of this onto the other side, which would be at positive z equals 2.92. And our shaded area is going to be this stuff over here and this stuff over here, the two tails. Of course, remember the stuff here and the stuff here are the same, so if we just find one of the two and double it, we should be all good. Well, it's always easier to look up the negative one so that the stuff to the left matches up with this. So let's go ahead and look up negative 2.92. So we can look that up on table A. There's negative 2.9012. So it looks like we should use 0.0018. So if we do that on table A, we should get 0.0018. So as we said, that would be the stuff this way, 0.0018. And as mentioned, we'll have to double that to actually get our p-value. So our p-value here is 2 times 0.0018, which is 0.0036. So there's our p-value there. All right, we're then ready to go ahead and make our conclusion. So conclusion here, this p-value compared against an alpha of 0.05, this is about 0.36%. This is 5%. So our p-value is much smaller. That means we are rejecting HO here. So if we think about rejecting HO, that means we are throwing this guy out and going with this claim that the percentages are not equal. In other words, that there is a difference here. So we'd say significant evidence that there is a difference in the percentage of U.S. adults who believe global warming is a serious issue compared to Canadian adults. So in other words, we would say that given the information we had here, right, there is significant evidence to believe that there is sort of a difference in opinion in the severity of global warming between U.S. adults and Canadian adults. We are convinced by that. Even though we only talked to 250 and 150 adults from each population, there was a big enough difference in those two samples to really believe that there is a difference between the two populations. Okay, so there we go. There's your guys' first example of running a two-sample proportion hypothesis test. Notice that we did detect that there is a difference in the percentages. So the next thing we're going to do is we're going to go ahead and build a 95% confidence interval to try to estimate that difference. So let's go ahead and do that. So we'll move on to part B here. For B, we want to come up with a 95% confidence interval for the difference in percentage of U.S. adults who believe global warming is a serious issue compared to Canadian adults. Okay, so we are going to try to do that. And again, since it mentions percentage, we know that that's going to be one of our proportional confidence intervals. Since it talks about the difference in percentage, that's going to tell us that it's a two-sample proportion confidence interval. So we're going to do this as a two-sample proportion confidence interval. So let's go ahead and start with our conditions. Well, these are the same as the hypothesis test. So same as hypothesis test. Check. So we already checked those. So we can jump right in to the construction here. So for the construction, we'll be doing P1 hat minus P2 hat, close that up, plus or minus Z star, square root, P1 hat, 1 minus P1 hat, over N1, plus P2 hat, 1 minus P2 hat, over N2. Parentheses there as well. Okay, so to fill that in, we will need to know P1 hat, N1, P2 hat, N2, and Z star. Now, a lot of these things we've already done. P1 hat, if we look back, all right, P1 hat was 0.62 and P2 hat was 0.76. So we can just go ahead and put all those things in there. 0.62, 0.76. This guy was 250. This guy was 150. For Z star, we can look that up on table C. We can do Z star and our confidence level as 95%. But we've done 95% in Z star a couple times already. We should remember that that's going to come out as 1.96. Let's just go ahead and remind ourselves, though. Right? If we look here, and we zoom out, right? There's our 95%. A little bit more. There's our Z star. There's our 1.960. So that does confirm what we've seen from our other videos there. So our Z star here, 1.960, and we can make use of that. Okay, let's throw everything in there then. So we get 0.62 minus 0.76 plus or minus 1.960 square root 0.62 1 minus 0.62 divided by 250 plus 0.76, 1 minus 0.76 divided by 150, and that square root does apply to all of that. So, as always, when you're doing one of these confidence interval for differences, you'll need to do this calculation and this calculation separately. So, 0.62 minus 0.76, this guy out here should be minus 0.14 plus or minus. Now we can, if we follow these parentheses, just type this in directly, 1.960 times the square root, parentheses 0.62 times parentheses 1 minus 0.62 divided by 250 plus parentheses 0.76 times 1 minus 0.76 divided by 150. We do all that, and it looks like we should get 0.091. Now go ahead and do your addition and your subtraction. So do your subtraction first, 0.14 minus 0.091. So that would be minus 0.231. And then the addition, minus 0.14 plus 0.091. And that would be minus 0.049. There we go. Then we can go ahead and write our interpretation. We will say that we are 95% confident that the difference in the percentage of U.S. adults who believe global warming is a serious issue compared to Canadian adults is between, you can convert these into percentages if we like, is between negative 23.1% and negative 4.9%. So this is a very safe way of interpreting it. Of course, you could also say that we are 95% confident that between 23.1% to 4.9% less of the U.S. adults compared to Canadian adults believe that global warming is a serious issue. The only danger of writing that interpretation, which was actually the one we favored when we did this for quantitative data, is that a lot of times when people hear the percentage less, they're actually imagining it not as a subtraction of percentages, but actually as a percent deduction, sort of like something like when you get a discount or something. And that's not really what this percentage means. This is talking about the percentage of people who fall into these categories. So I would actually recommend when doing a two-sample proportion confidence interval, you stick with this very sort of strict description here, where we describe it as the difference in the percentage. Okay. Let's wrap this example up by talking a little bit about the errors that were possible in this situation. So we want to talk about the type 1 and type 2 errors. Let's go ahead and just go back and grab what our hypotheses were. So remember that our hypotheses were these guys right here. Let's go ahead and grab that correctly. There we go. So we just want to grab that. Okay, so always useful to have your hypotheses when you're trying to talk about the errors here. So remember, those were our hypotheses. Okay, so let's talk about the type 1 and type 2 errors here. So for type 1, we know that that is reject HO when HO is true. So that would mean that we're throwing this guy out, believing that there is a difference, when really there is no difference. So this is where we believe there is significant evidence for a difference in the percentage of U.S. adults who believe global warming is a serious issue compared to Canadian adults. So that would be the rejecting HO part. So everything we just wrote there, we believe that there is significant evidence for a difference in, okay, that is all that. Now we need to say when HO is true, when in reality, well, HO being true means that the percentages are equal, so that means there is no difference. When in reality, there is no difference in the percentage. So, no difference in the percentage. All right, let's try that for type 2 as well. So type 2 is where we fail to reject HO when HO is false. So again, we'll try to describe what that'll look like, and then we'll describe what this will look like. Well, we know that failing to reject HO basically is going to say the same thing as this, except that there is no significant evidence. So this is where we would say we believe there is no significant evidence for a difference in the percentage of U.S. adults who believe global warming is a serious issue compared to Canadian adults, when in reality, okay, so once again, all of that language there was just about what it meant to fail to reject HO. When in reality, HO is false, meaning that this guy is wrong and this guy is correct, meaning that there is a difference. So when in reality, there is a difference. Oh, that's not how we're writing. Let me just go back there. When in reality, there is a difference in the percentage. And that little part right there, that would be describing HO being false. As always, if you look at these two error types, right? Type 1 should be a false positive. We think there's a difference when there really is no difference. So we think something is going on when it's really not, a false positive. And type 2, as usual, is a missed effect. We say that nothing is going on. There's no difference between U.S. adults and Canadian adults. But in reality, there really was a difference and we missed it. In our next video, we'll look at one more example of running these two-sample proportion procedures. But in general, you guys have now seen all the sort of pieces of these new pair of procedures.